Hi, welcome to today's session of math problem solving. Um, Today we're going to be doing an activity. Prime numbers is a fascinating topic in number theory in math. And the problem today is how many prime numbers exist which are less than 200. Now, many people might know the prime numbers that are less than 100, but oftentimes we don't go beyond 100. But today we're going to go. So to do that, I have two hundreds chart. So the first chart here is between 1 to 100. The second one, we need to assume it's between 101 to 200. Okay, so we're going to use the same logic of eliminating the numbers that are non-prime. The composite numbers, if they're eliminated, what is left over is going to be the prime numbers. So let's start by marking the smallest prime number, which is 2. 1 is neither prime nor composites, but still for all practical purposes it's not prime, so we're going to darken that. Now if 2 is prime, then you know that every single factor of 2, which is all the numbers ending in 2, all the numbers ending in 4, all the numbers ending in 6, all the numbers ending in 8, and all the numbers ending in 0, which means all the tens, multiples of tens. This same thing is going to apply for all the numbers beyond 100 as well. So 102, 112, all of these guys are also going to be composite. So let's mark them out completely as dark. So this is our first level of elimination. For the second level, even though 3 is actually going to be a prime number, we're not going to select 3. For sake of convenience, we're going to select 5 first. The reason is 5 has a very similar effect to 2, which is it can eliminate all the numbers which end in 5. So therefore, all the multiples of 5 that end in 5 is going to be non-prime or composite. So that kind of narrows the field down. So we know that all the prime numbers need to end in an odd number. They either need to end in 1, 3, 7, or 9, any value. So it's just about dealing with a total of 79 numbers before we can start eliminating a few more. Okay, now let's start with 3 next. Now, 3 has an interesting property. If a particular number in a column is going to be a multiple of 3, then every number that's 30 more than that is also going to be a multiple of 3. So if 21 is a multiple of 3, which it is, 51 is, 81 is, and by that extension, 111 is, which means 141 is, which means 171 is. So these are all multiples of 3 for numbers ending in 1 with units digit 1. For numbers ending with units digit 3, it's 33, 63, 93, and therefore it goes to 123, 153, and 183. Now let's go to numbers ending in 7. 27 is the first number, so 57, 87, and therefore you know that it's 117, 147, 177. And you can do a quick check. 177 is nothing but it sums up to 15 and therefore multiple of 3. For 9, it starts with 9, so 39, 69, 99. And you can go on the next level, which is 30 more than 99, which is 129, 159, and 180. All right, now comes 7. Now, the interesting observation to make here is, if there is actually a number which is multiple of 7, then it's not a multiple of 235, because if it were a multiple of 235, it would already be eliminated. So it has to be 7 times something else, and that something else also needs to be a prime number. So you can immediately see, you can start with 7 times 7, which is 49, 7 times 11, which is 77, 7 times 13, which is 91, and you can go on. What is 7 times 17? 7 times 10 is 70, and 7 times 7 is 49, which means it's 1 less than 120, so you can go to 119 and mark that as a multiple of 7. And you can go back, that takes 7 times 17, so it's 7 times 19. So that's just going to be 14 more than the previous number. So we blocked 119. So 14 more than that is going to be 133, which makes sense because 140 would be 7 times 20. So 133 is 7 times 19. So I can eliminate that as well. What about 7 times 23? 7 times 20 is 140. 7 times 3 is 21. So if I add them together, it needs to be 161. What about 7 times 29? 7 times 30 is 210. 7 times 29 has to be 7 less than 210, which is 203. And therefore, the limit for 7, if you want to target all prime numbers less than 200, is 20. What about 11? Now, you're going to apply the same thing again. If 11 were the number you're considering, then the multiple of 11 should be a product of 11 and another prime number. So 11 times 11 is the start, which is 121. 11 times 13. So that's 130 plus 11, which is 143. So you can go here and mark this out. 143 is the next one. What about 11 times 17? So that's 170 plus 17. So 170 plus 17 is 187. So that's 11 times 17. What's 11 times 19? So 11 times 19 would be 11 times 20, which is 220. This or 190 plus 19, which makes it 209, and therefore you need to stop it there. All right, extending the same logic, if you start with 13, then you know that 13 times 13 would be the first elimination, which is 169. And what about 13 times 17? 13 times 17 would be greater than 200, right? So 17 times 10 is 170. 17 times 3 is 51. Add them together, it's 221. So it stops there. Okay, so what about 17s? What's 17 times 17? So 17 times 17 is 289. So you've crossed into the 200 territory. Now, whatever you're left with has to be a prime number. So 17 is a prime number, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97 are all primes. Not only that, 101, 103, 107, 109, 113, 131, 127, 137, 139. 149, 151, 157, 163, 167, 173, 179, 181, 191, 193, 197, and 199 are all primes. Let's do a quick check. Is there any number here that we can pick randomly and check? I think not. So most likely these are going to be the prime. But I haven't verified if these are the primes between 100 to for numbers between 100 to 200. Okay, but answering our question, we have 5 plus 7 plus 6 plus 5. So 7 plus 6 is 13, 13 plus 10 is 23, 23 plus 2 is 25. So 25 primes here, and you have 5 plus 5 plus 6 plus 5. So that's 21 primes. 25 plus 21 is 46. If there is a number which is a prime that I have already missed out, or if one of these numbers are not prime, please do leave your comment and I will ensure that we look at that and we fix the problem. All right, thank you so much. I hope you found this video interesting. If so, please do like, share, and subscribe. Thank you so much. I'll see you in the next one.